Here, we are being asked to solve a non-right triangle. The given information is a side, then an angle, and then another side. Two sides and their included angle. To solve a triangle, you must find all missing sides. In this triangle, we are missing angle A, angle B, and side C. Note that side C is opposite angle C. In triangles, usually, sides are labeled with a lowercase letter, the same letter that the angle opposite is labeled with as a capital letter. To solve a non-right triangle, such as this one, when given side, angle, side, trigonometry must be used. When solving a triangle, given side, angle, side, first, we're going to find side C using the law of cosines. In general, if you were given a side and then an angle and then a side, the first step is to find the side that is opposite the given angle using the law of cosines. After finding the length of side C, the order in which we find the remaining two angles, A and B in this diagram, can be interchanged. What we will do here is next find angle A using the law of sines, and finally, once we know angle A and the given angle C, we can find angle B simply by subtracting from 180 degrees. Let's begin by finding side C using the law of cosines. The law of cosines states that in any triangle, the measure of one side of the triangle squared is equal to the other two sides squared added together, the sum of the square of the other two sides, minus 2 times the lengths of the other two sides times the cosine of the angle that is opposite that side. In this problem, we are going to first find the measure of side C, the length of side C, I should say. And C squared is equal to A squared plus B squared minus 2 times A times B times the cosine of angle C. Substituting the values in this problem into the law of cosines, we will get C squared equals A squared, 10 squared, plus B squared, 14 squared, minus 2 times A times B, 2 times 10 times 14, times the cosine of angle C, the cosine of 105. When simplifying this expression, I'll first square 10 and 14, as well as multiply 2 times 10 times 14 to find that C squared is equal to 100 times 196, 100 plus 196, minus 280 times the cosine of 105 degrees. Adding 100 and 196, I get C squared equals 296 minus 280 times the cosine of 105. And at this point, before typing anything into a calculator and making any approximations, I'll take the square root of both sides of this equation. I want to isolate C in this equation, find the length of side C. So to isolate C, I'll have to take the square root of both sides. I will not have to add a plus or minus in front of the number on the right side of the equation because C represents the length of a side, which will always be positive. A negative length of a side doesn't make sense in this context, so I don't have to worry about the plus or minus. So I found that C equals exactly the square root of 296 minus 280 times the cosine of 105. I'll approximate this to the nearest tenth and find that C equals 19.2 meters. The first step of solving this triangle, finding the value of C, is complete. C is approximately 19.2 meters. Let's move on and find the measure of angle A. To find the measure of angle A, I'm going to use not the law of cosines, although I could use the law of cosines. It will be easier to find angle A using the law of sines. The law of sines says that the sine of angle A over side A is equal to the sine of angle B over side B, which is also equal to the sine of angle C over side C. In this problem, now that I know side C and I was given angle C, I can use the law of sines with the sine of C, sine of angle C over side C ratio, and set that equal to the sine of angle A over side A. When I do that, I have an equation where there is only one unknown, the measure of angle A. I have the sine of angle A over 10, side A, equals the sine of angle C, 105 degrees, over side C, 19.2. And I can solve this equation by cross-multiplying 19.2 times the sine of A and 10 times the sine of 105. And that gives me 19.2 sine A equals 10 times sine of 105. I'm trying to isolate angle A. I'm trying to find the measure of angle A, so the next step would be to divide both sides of this equation by 19.2. And if the sine of angle A is equal to 10 times the sine of 105 over 19.2, then the measure of angle A is equal to the inverse sine of 10 times sine 105 over 19.2, which is, to the nearest tenth, 30.2 degrees. 30.2 degrees. This is the measure of angle A in this triangle. It is worth noting that the inverse sine of 10 sine 105 over 19.2 has another answer between 0 and 180 degrees. It's also equal to 149.8 degrees. But in our triangle, angle C is already known to have a measure of 105 degrees. There's no way that angle A could be 149.8 degrees. Angle A is 30.2. Now that we know angle A and we're given angle C, the final step in solving this triangle, finding angle B, will be very straightforward. If you know two angles of any triangle, you can easily find the third angle by subtracting from 180. The sum of the three angles in any triangle is equal to 180 degrees. So if I want to find angle B and I know angle A and angle C, I'll simply subtract 180 minus 105 minus 30.2 to find an approximate value of angle B. I'm saying that this is an approximate value because remember, angle A has been approximated. It's approximately 30.2 degrees. Angle B equals approximately 180 minus 105 minus 30.2, which is 44.8 degrees. We've now solved the triangle that was given in this original problem. In this original problem, we were given two sides and their included angle. We used the law of cosines to find the remaining side, side C in this case, to be 19.2 meters. Once we knew what side C was, we could use the law of sines to find angle A, and then simply subtract from 180 to find angle B.